Hey friends, we're back with American Miscellany. So we are now on essay number 113. It's about divisions of the globe. And we were told at the very beginning on the frontispiece of this beautiful book that not only that this book was published in 1865 by a Mr. Robert Sears, but also that these essays are intended to be historic and scientific. So I'm curious. I think we're probably going to get, hopefully, a more scientific look at divisions of the globe. Who knows? Historic, I guess, would be fine too. But our previous essay was on American scenery. That was essay number 112 on American scenery. Nice, but rather long and tedious. This one doesn't seem quite so long, so I assume we're not going to go deep into the history of the divisions of the globe. We're here on page 278 of American Miscellany. So let's dive into essay number 113. Divisions of the globe. The natural divisions of the surface of the globe is into sea and land, about 3/4 of the whole being occupied by water, although probably nowhere to a depth beyond 2 or 3 miles. The remaining fourth consists of land elevated more or less above the level of the sea, interspersed in some parts with smaller collections of water at various heights, and in a few instances somewhat lower than the general surface of the main ocean. Thus, the Caspian Sea is said to be about 300 feet lower than the ocean. And in the interior part of Africa, there is probably a lake equally depressed. Probably. We cannot observe any general symmetry in this distribution of the Earth's surface, except that the two large continents of Africa and South America have some slight resemblance in their forms, and that each of them is terminated to the eastward by a collection of numerous islands. The large capes projecting to the southward have also a similarity with respect to their form and the islands near them. To the west, the continents are excavated into large bays, and the islands are to the east. Thus, Cape Horn has the Falkland Islands, the Cape of Good Hope, Madagascar, and Cape Comorin, Ceylon, to the east. The great continent, composed of Europe, Asia, and Africa, constitutes about 1/7 of the whole surface of the earth, America about 1/16, and New South Wales about 1/5. Or in 100th parts of a whole, Europe contains 2, Asia 7, Africa 6, America 6, and Australia 2, the remaining 77 being sea, although some authors assign 72 parts only out of 100 to the sea and 28 to the land. These proportions may be ascertained with tolerable accuracy by weighing the paper made for covering a globe, first entire and then cut out according to the terminations of the different countries. Good method. Or if still greater accuracy is required, the greater part of the continents might be divided into known portions of the whole surface, and their remaining irregular portions alone weighed. It will be seen, even by a superficial glance at an artificial globe, that the great preponderance of land lies to the northern hemisphere, or half. All the continents lie in this direction, and to the south is a wide expanse of ocean, studded with numerous small and scattered groups of islands. It will be observed, too, that the continents stretch from the North Pole towards the equator and South Pole, or parallel to the lines of longitude, not across or parallel to the equator. The general inclination and levels of the continents are discovered by the course of their rivers. Of these, some of the principal are the Amazon, the Missouri, the Mississippi, the Niger, the Arkansas, the Nile, the Kianku, the St. Lawrence, the Huangho, the Amur, the Rio del Norte, the Volga, the Yangtze, the Obi, Yangtze, the Obi, the Danube, the Indus, the Orinoco, the Ganges, the Euphrates, the Senegal, and the Dnieper. And this is nearly the order of their magnitudes. We may form a pretty accurate idea of the levels of the ancient continent by tracing a line across it in such a direction as to pass no river, which will obviously point out a tract of country higher than most of the neighboring parts. Beginning at Cape Finisterre, we soon arrive at the Pyrenees, keeping to the south of the Garonne and the Loire. Keeping to the south of the Garonne and the Loire. Okay. After taking a long turn northward to avoid the Rhine, we come to Switzerland, and we may approach very near the Mediterranean in the state of Genoa, taking care not to pass the branches of the Po. We make a circuit in Switzerland and pass between the sources of the Danube and the branches of the Rhine and the Swabia. Crossing Franconia, we leave Bohemia to the north in order to avoid the Elbe, and coming near to the borders of Austria, follow those of Hungary to the south of the Vistula. The Dnieper then obliges us to go northward through Lithuania, leaving the Don wholly to the right, and the Volga to pass still further north between Petersburg and Moscow. We may then go eastward to the boundaries of Asia, and thence northward to Nova Zembla. Here we descend to the west of the Obi, and then to the east of the branches of the Volga and the other inland rivers flowing into the lake Aral and the Caspian Sea. Here we are situated in the widely extended elevation of India, in the neighborhood of the sources of the Indus, and lastly, in our way hence towards Kamchatka, we leave Yangtze and Lena on the left, and the Ganges, etc., on the right. The direction of the most conspicuous mountain is, however, a little different from this. The principal chain first constitutes the Pyrenees and divides Spain from France, then passes through Auvergne to join the Alps, and through the south of Germany, Dalmatia, Albania, and Macedonia. It is found again beyond the Euxine under the names of Taurus, Caucasus, and Imas, and goes on to Tartary and Kamchatka. The peninsula of India is divided from north to south by the mountains of Gate, extending from the extremity of the Caucasus to Cape Comorin. In Africa, Mount Atlas stretches from Fez to Egypt, and the mountains of the moon run nearly on the same direction. There is also a considerable elevation between the Nile and the Red Sea. In the New World, the neighborhood of the western coast is in general the most elevated. In North America, the Blue Mountains or Stony Mountains are the most considerable, and the mountains of Mexico, had they not discovered the Rockies yet? It says 1865. They must have known about the Rockies in 1865, no? Okay, in North America, the Blue Mountains or Stony Mountains are the most considerable, and the mountains of Mexico join the Andes or Cordilleras, which are continued along the whole of the west coast of South America. There are several points in both hemispheres from which we may observe rivers separating to run to different seas. The highest mountains in the world are the Himalaya range in Asia, which are upward of 28,000 feet. Chimborazo in America, 21,000. The Abyssinian Mountains in Africa from 10 to 15,000. Mount Blanc in Switzerland, 15,000. And the Apennines upward of 9,000 feet. The plains of Quito in Peru are so much elevated that the barometer stands at the height of 15 inches only, which at the level of the seas stands to 30 inches. Thus the air is reduced to half its density. But none of these heights is equal to 1,000th part of half the Earth's diameter, and the greatest of these might be represented as grains of sand on a 6-inch globe. The internal parts of the body of the Earth are little known from actual observation, as the deepest mines or excavations are comparatively as but scratches at the end of an apple. The real density of the Earth, then, beyond the mere surface, is but matter of conjecture. From observations on the attraction of the mountain Schehallien, Dr. Miscellany supposed the actual mean density of the Earth throughout all its mass to be that of water as 4½ to 1, judging from the probable density of the internal substance of the mountains, which he supposed to be solid rock. Mr. Cavendish has concluded more directly from experiments on a mass of lead that the mean density of the Earth is to that of water as 5½ to 1. This density assigned by Mr. Cavendish is not all greater than might be conjectured from observations on the vibrations of pendulums. The great Newton had long ago advanced it as a probable supposition that the mean density of the Earth might be about 5 or 6 times so great as that of water, and the perfect agreement of the results of many modern experiments with this conjecture affords us a new proof, in addition to many others, of the accuracy and penetration of that illustrious philosopher.